Hello, in this video, we are going to learn about an important data structure in Python named linked list. So, what is a linked list? A linked list is a fundamental data structure in computer science that consists of a sequence of elements called nodes, where each node points to the next node in the sequence. These boxes represents a node, where this first part of a node is called data part, and the other part is for next pointer, which points to the next node in the linked list. And the end of a linked list points to null pointer. So what's the difference between arrays and linked list? So you can see this is the representation for an array, and this one is for linked list, where this is head, or you can say start pointer, which tells us where the linked list starts. So in this case, it's starting from address 103. And these are the addresses for other nodes in linked list. So let's see the main differences between them. On the basis of memory allocation, you can see arrays uses contiguous memory allocation and linked list non-contiguous. So what's contiguous memory allocation? Here you can see that the first address for this array is 200, and the next value is stored at address 204, and then similarly 208 and 212, with the gap of 4 bytes for this storing this data value. This is contiguous. Here in linked list, our first node is present at this address 103, and the next node is present at address 1000. So it's a huge gap. So it's not necessary that you have to directly allocate the next node after this address pointer or to the next address pointer. You can allocate it anywhere, but you have to make sure that you're storing the address of the next node in the next pointer of the previous node. Like here, this data 35 is stored at this data pointer of this node, and the next node's address is stored in its next pointer, which is 1000 here. Similarly, for this address, we are storing it in this next pointer, and this one here, and at last we have none, which represents that this is the end of linked list. So you can see these address locations are not contiguous. Means in our memory we might have a location 3004, and we might have stored something else there. So it's not necessary that we have to allocate the memory locations contiguous in linked list, but it's mandatory in arrays. Now coming to the next difference, it's for size. So arrays have fixed size, but linked list have a dynamic size. Means, let's say in this example, we have the size of, we have 4 elements, so its size is 4. So while creating this array, we have to initially tell that our array is going to be of size 4, but it's not necessary in linked list. As you can see, we just need the next pointer, so you can choose any random location and then add it to your linked list. So there's no need to have a fixed size for linked list. Now next difference is the time complexity for random access. So arrays have faster random access. Its time complexity is big O of 1, whereas linked list are slow. Its time complexity is big O of n. Let's say you want to access this element, then in arrays we just need its index. It is present at index number 2, 0, 1 and 2, so we can directly access it from here. But if we want to access, let's say in linked list, then we have to first go iterate through each node and then check whether the element is present or not. So this its average time complexity is big O of n. After that, insertion and deletion. So arrays insertion and deletion is slow. It takes big O of n time, and linked list takes only big O of 1 time. So when you want to, let's say, add element to array, let's say at the beginning, then you have to shift all the elements after it one at +1 index, means shift them towards right. So it's gonna take big of n time for average insertion. And similarly for deletion, you will have to, let's say if you want to delete this element, then you have to shift the others towards left. So that's why it's consume time. But in linked list, if you wanna insert a new element anywhere, then you just have to change the next pointer of one or two nodes. And similarly for deletion, you just have to, let's say you want to delete this element, you want to delete this node, then just allocate the next pointer of this node to this one. Means you will store this 3000 value at its next pointer, and this node will be deleted. So you don't have to shift any of these, or other nodes of linked list will be kept unchanged. After that, iteration in array, it's fast but it's slower in linked list, and memory overhead is higher in arrays but it's lower in linked list. And these are the use cases. So if you want to use a data structure where you can access elements faster, then you should use arrays. But if you want a data structure with dynamic data allocation and with frequent insertions and deletions, then you must use linked list. So that's the theoretical part for linked list. Now let's see its implementation in Python. For linked list, we require nodes. So first of all, we are going to create a node class. In the node class, we have to define a function for the initialization of node and pass the self and data parameter here. So a node consists of a data part and a next node address in case of simple linked list. So here we have to assign our data and the next node address. So to assign the data, we will use self.data is equal to data, and the next will be set to none initially. What this will do, whenever we want to use this node class, we have to pass this data parameter for initialization, and this data will be assigned to this self.data, and the next node will be set to none initially. So this was for node class. Now we'll create our linked list class. So to do that, simply write class, then give the name for class, in this case linked list. After that, similar to this node, we have to pass a init method here, pass the parameter self. And in case of linked list, initially when a linked list is called, then we have to create a self.head, and initially its value will be set to none. So this is the code for doing that. And if you are getting confused with this class and these methods, then I would recommend you to learn the OOPS concepts of Python, and then you won't be getting confused in this. So now our initialization method is defined here. After that, in our linked list class, we have to add methods that we use, like insertion methods, deletion, and a method to print our linked list. So we will be adding them one by one. First of all, let's start with insertion. And insertion can also be done in many ways, like we can insert the new node at the beginning of the linked list, so it's insertion at start. Similarly, we can do at the end, or we can do it in middle also. So first of all, let's create a method for inserting a node at start of linked list. For that, we have to define a method and give it a name. I'm saying insert at start. After that, we have to pass the self parameter, and for insertion at starting, we require the data for our node. So data is a must parameter here. And so initially what we have is we have the head at none. So what we have to do is we have to create a node and then assign its next to none and set our head to this node. This will be the case when our linked list is empty or none. If our linked list has other nodes also, let's say like this one, node 1, then node 2, node 3, and then none. And let's say if our linked list look like this, so what we can do is we have to create a new node and insert it at this start. So this is start, or you can also say it a head. So to do this, we will create a new node first, and after creating that node, we are going to assign the next of this new node as this node 1, which was the start node initially, where the start was initially. And so to implement this functionality, what we will be doing is, so our first step is to create a new node. And to create a new node, let's give it some name. Let's say new node, and in new node we will be using this node class, and for this data we are going to pass this data parameter. So what this line will do is it will create a new node with the data which we passed to this method, and it will assign this data here to this self.data, and our self.next will be set to none initially. We can change it also. Now our new node is created. After that, we have to link this new node to this linked list. So we can do this by setting the next, by assigning the next of this node to this node. So for doing this, what we are going to do, we are assigning the new nodes next to the head. So initially head, or you can say it head or start. Initially head was at this node. So we have the address of this node in our inside our head. So I can pass the self.head here. We also have to assign the head to this newly created node, so that our head will be at this one, starting at start. So to do this, we can simply write self.head is equal to this new node. So let's try running our program first. First of all, we have to initialize this class. So I'm creating a variable L, and now this L is a linked list. So let's try inserting first. L dot insert at start and give some data for our node. Let's say 15. And if I run it, then it is not showing any errors, means everything is working fine. And if I try printing this linked list, then it's showing main list, linked list object at this address. And to see the content of our linked list, we can create a new function. Let's say print and pass this self here. We don't need this data parameter here, as we are already having the contents of our linked list. So we just have to print them. And to print the content of our linked list, what we can do is create a temporary variable let's say 10, or just say current head. Give the self to head value to this current head. Now our current head is present at the start or this self dot head of our linked list, and for getting the data from all these nodes we have to iterate one by one until we reach this none value. So what we can do is just simply say while current head is not equal to none, simply print the current head dot data, and after printing the data, let's say now initially current head is at starting, the data for this node is printed. Now we have to go to next node. So for going to next node we can just say current head is equal to current head dot next. So it will keep moving to the next node or the next address. Let's use this print method of our linked list. So just write l dot print, and let's see. Okay, so it's showing the first 15. So this is the content of our node. As we have only created a single node here, it's showing the content of this. Let's try creating some more nodes and give them some random values. Now let's print it. Okay, so it's printing the values correctly. See, we are inserting 15 at start. So first of all 15 got inserted at start, then 785 comes at start, not then 255, and after that, after this last command, 55 got added at the first. So its insertion at start is working perfectly, and our print function is also showing the contents correctly. Now just for better view we can write this. So this will insert this string in between these node values, so it will be easier to see the outputs, and also we can just print none at the end of string. Yes, it's now more clearly visible. So we have created these two basic methods for the linked list. Now after that we can try out more methods like insert at the end of linked list, so that the order will be like this one: 15, then 785, 255, and 55. Not this one in reverse. So to do that, let's create a new method. Give it a name. I'm giving insert at end self, and as we are going to insert at end, so we already know the position where our data node is going to be added. We just need the data for creating our node, and just like we created a new node here, we are going to create a new node for inserting at the end. And now as we are going to insert at the end, we have to check if this linked list is empty, then we just have to create a new node and assign it as the head. And so to check for that we can write if self.head is equal to none, then simply say self.head equal to new node, means head is at this new node, and we don't have to assign the none for next, because while creating the new node we are already assigning it its next to none, so we don't have to change anything here. After that, if that's not the case, then else condition. So our head is not none, means it's a linked list containing some nodes like this one, and here what we have to do is we have to insert our node in between this none and this last node. To do this, first of all, we can create a temporary variable, call it current head, and assign float head to this one variable. And what we can do is we will just initially our head will be at this location, so we will iterate one by one until the next of our current node is not none. So if we reach this last node, then when we perform current head dot next, then its value would be equal to none. So we get to know that this is the location where we will be inserting our new node. And to do this, we can simply write while current head dot next not equal to none. We will just keep assigning our current head to the next location. And after we got current head dot next is equal to none, we can just assign the next of this node to our newly created node, like this one. Current head dot next would be equal to new node. So the next of this node will be pointing to our newly created node, and the new node will be pointing to this none as we initialized it here. So this will do the task for us. Let's first try for this function. Let's say insert at head, and I'm inserting some random values. And now into the data of our linked list. When I run it, okay, so this was for our insert at start, and this one is same till here. And after that, when I perform insert at end and added 230, so it added 230 after this last node and before this none. And similarly with these commands, it keep adding the new nodes at the end of the linked list, and the last node is pointing to the none. So this is working perfectly. After that, we also have one more basic function for linked list, that is deletion of the nodes. So to delete, we have some other ways, like we can delete the nodes by its key value or its data. So like let's say this node has 255 data, and I want to delete the node with this 255 value. And we can also delete the nodes based on the position, like the index of the node. Just like in this example, in this linked list, this one is at index 0, index 1. So if you want to delete this node, I can just delete it by passing its index, that is 1. So first of all, we are going to create a method which deletes the nodes based on the data of node. So to do that, just define a method. I'm naming it as delete node, pass the self, and we are going to delete on based of data, so we need data parameter here. And to delete nodes in linked list, how are we linking these nodes? So we are linking these nodes based on the next value of these nodes. So this node 1 is linked to this node 2 because the address, the next of this node is pointing to this node. And let's say I want to remove this node 1 from here. So what I can do is I can just assign the next of the previous node, in this case this one, to its next node, which is this one. So I can just assign the new node dot next to node 2. So this node 1 will be removed and this will be pointing toward this node. So let's use this concept. We can just assign a temporary variable that its value to set dot head. For deletion also, we might encounter a case where our linked list is none. For that, we will just write if current head. So if current head, what this checks is whether this value is not assigned to none. So if that's the case, and our current head dot data matches this data, let's say it's a key, so that you don't get confused. So this key is the data which we are going to delete. So if the data of node is equal to this key, then what we have to do is simply set the self dot head to the current head dot next. This one is for key at first node. So our start is our head is this at this first node, and the data of this node matches our key. So what we have to do is we have to now assign this head to the next of this node, which is none in this case. So this is the code for doing that. After that, if the key or the data to be deleted is present at some other nodes rather than the first one, or it's not present in the linked list, then for that we have to iterate through all the nodes. We can use this current head dot data is not equal to the key, and our current head is not equal to none. So if that's the case, we will be just incrementing, or we will be just iterating through the nodes by going to the next head node by one. And I missed one more thing, that while in the case of a linked list having multiple nodes, when we are deleting a node, let's say we are deleting this node, so we also have to keep note of the previous node, and for previous node we will be just keep storing the previous node in this variable called previous node and pass the current head here. So when I first go to this node, when current head is at this node, our previous node value is equal to this node, and now I incremented our current head to its next. So current head got here and previous node value is still this one, and if our key matches this node's data, which is this case, so we have the previous node value as this one, and we also have the current head. We just have to set the next of this previous node to the next of this current head's node which we want to delete. So this will just do this thing. So the node between them will be deleted. So this will be directly linked to this node. Okay, after all the traversing, first of all we have to check, and when I forgot to assign this previous node here, so first just assign it, set its value to none. We will be checking if our current head is none, means after iterating we reached this none, so means the key which we are finding, which we want to delete, is not present at any of these nodes. So we can just simply say return or say something like the key or the data you want to delete doesn't found at any node. And otherwise, if that's not the case, then what we have to do is set our previous node's next value to the next of our current head. And also make our current head or current node equal to none. We are doing this step because our deletion is already completed here, and we are doing this step so that the space used by this node will be get empty, or the data present here at this node will also get deleted. So this is all we have to do for deletion. Now let's try it out. Let's say I want to delete the node having data is equal to 255, and after that printing our linked list, running it. Okay, so this was our linked list, and after I perform the delete operation, you can see this node having 255 data got deleted. So it's working perfectly. You can try them out, and also I'm not going to explain other methods. You can try them out on your own, like deleting the node. You can also perform tasks like deleting the node based on the position or index. For that, you will first get an index value from user. Let's say index number 1, 2, 3, like this, and we will just keep iterating to our nodes until we will also be keeping a counter, like keeping a counter, and we will increment it each time we iterate through a node. And when the count variable matches the index of the node to be deleted, then we will simply perform this delete action. So we will be keeping note of this previous node for that case also for deleting. So you should try, you can try it out on your own and ask your doubts if you have any. So that's all for this video, I guess. Oh wait, I missed one more. Let me also teach you how to insert at mid or insert at specific position. That's also an important function. So let's say insert means we have some linked list with some nodes, and we want to add a new node in between this node of linked list. For doing that, we must know the previous node's address, and for creating a new node, we need data. Just pass the parameters here, previous node, which will be storing the address for previous node, and after previous node, after which data our new node has to be inserted, and the data for creating new node. So similarly, for creating new node, just use this. And before that, as for this function, we are going to insert the node after some already created node in the linked list. We must check if there is a node present or not in our linked list. To do that, we can just simply check if previous node is none. This will check if our linked list, if the previous node value is equal to none, and if it's equal to none, then we can just show some message like the previous node is not valid or something like that, and we can just return from there. No need to create a new node. And if that's not the case, then we have to create a new node. Just say the next of the new node. Let's say I want to insert a node named node1 here. To do this, already know the address of previous node, but to add this node to this linked list, I also have to assign the next of this node, newly create added node, to this node. I can get this node's address from this node. So this node is stored at the next of this one. So I can simply assign the next of this node as next of these nodes. So new nodes next will be equal to the previous nodes next. And we also have to create this link here between these previous node and new node. So to do that, we just have to assign this node to this node's next. So this is one is previous node. So just do previous nodes next is equal to new node. And that's it. And let me show you an example. Let's say I want to insert that node after this node. So I can just something like that, l dot insert after, and pass the previous node, which is this one in our case, and it's at the head is right now here, so it's at head dot next. You can access it using head dot next. So I can just write l dot head dot next. So this our previous node is this one, and let's say new data equal to 300, and after that I also want to print my linked list. After running that, as you can see, the new node with 300 data is added to the linked list after this node which we passed here. So this is also working perfectly, and that's all for this video. I hope you got the idea of linked list, how it works, and you know how to create a linked list and its method like that. You can try out more methods, like I said, delete node with some specific position, or methods like to get the length of linked list, and to search data at some index, something like that. So you can try them out, and you can ask your doubts in the comment section. Thank you.